Hi everyone, welcome to Kotlin London. Another month, another event, and a really big welcome to all the recent new joiners from around the world. Every month we're growing by dozens of new members. If you haven't already, please join up on the meetup page, hit subscribe here on YouTube, and follow us on Twitter. And of course, if you know someone who is willing to giving a talk on Kotlin London, just let us know. We have to thank, of course, our sponsor, 47 Degrees, for sponsoring the Kotlin London. Please check the training on Kotlin and functional programming. The link is in the description below. We also, if you're interested in streaming, we think StreamYard is great. If you want to start using it, please use the referral link that is in the description. If you sign up, you help us to get some money in terms of discount and reduce the cost for running the meetup. So we have two great talks tonight. As usual, we have two Kotlin GD, Arnaud Giuliani and Roberto Orgiu. Big fan for them to join us and share with their knowledge, of course. As usual, we hold a Q&A after each talk. This time we'll do it in a different way. Instead of using the sliders we did before, you can post this straight away, your question, into the YouTube chat. Please use the hashtag ask, so we know it's a question for the speakers, and we show them in the streaming. Of course, during the talk, if you want to show your encouragement, your just an emoji and a short feedback, or thumbs up in the chat, it's good for the speaker to have like a feedback or exactly what is going on, and not just staring at the screen and talking into the void. So thank you. Yeah, so the first speaker is Arnaud Giuliani. You probably know him as from Coin, but tonight he will talk about like writing the state flow. Up to you, or no?
No issue in me. Yeah. Here we go then. Yeah, let's go for this session, and let's talk about writing through the states. I'm Arnaud Giuliani. I'm very happy to be here tonight to share a bit of time with you and talk about Kotlin. I'm an Android engineer at BlaBlaCar. It's a French company about carpooling. And you may know me about my open source contribution, and I'm a Kotlin GD. Just one word about BlaBlaCar. It's a carpooling application that is well known in Europe, but also widely used in the world, because we have 90 million people using, and we are in 22 countries. Then it's very massive application, and it's not only about you using or sharing your car. It's also about marketplace for traveling and buses, and trying to share stuff to travel around the world. Okay, let's talk more seriously, and I would like today to talk about how we build application and mobile application architecture. The classical MVVP, MVVM, MV something. I would like to step back and say, okay, today I would like to look at what we are doing here. As the presentation layer, we have in the classical presenter or view model way, we try to abstract our business logic, and we try to solve things to help with our business logic here. I would like to share many issues I've seen around as I'm working in many companies, and this is usually the same. And I would like to say, yeah, why are we still having such issues with MVP and EVVM? And let's take back to MVP. Not to say that this is a bad pattern, just to say that we can have some issues with some usage. Like, it's a classical pattern when you link your view and the presenter in a one-one contract, which is usually an interface, and your presenter is managing your UI logic and dealing with the data and dealing with the interaction, and the view is displaying the data, is notified by the presenter and notifying for action. This is quite a simple and a very simple pattern in terms of architecture UI, but we can usually encounter some stuff like tight coupling between the view and the presenter with the logic. That means that finally, instead of keeping all your logic on the presenter side, you keep going on with your view and your presenter and the presenter and the view, and then your logic is completely mixed in that. And finally, you try to push inconsistent things to your UI. That means that finally, we don't know what's inside your black box that is your presenter. And finally, this is not really reactive, as a whole reactive approach like Rx or coroutines are done inside and are not pushed to the view. This is many classical issues that we can encounter in MVP. And finally, on MVVM try to push the abstraction of your business logic for the UI. Finally you expose streams of data to the view, which is interesting because we don't need anymore any kind of contract. And then your view is observing your streams of data and is triggering user action. This is interesting. And finally, you can still find lots of interesting articles around the world. I like those articles from Florian, from Lucia, that is, for me, a fundamental article about architecture, MVP, and MVVM, and why we go to such pattern. And in 2017, we have a good stuff from the Google Android team that bring the architecture components with the lifecycle API, the view model, and the live data. They bring us very interesting tool to write our business presentation. And then, is it just a matter of using streams? No. Finally, if you just try to push to put streams in your MVP and you still doing the same stuff, you will still be stuck in the same problem. That means that even in MVVM, you can be still very coupled, and you can still have data inconsistency. That means that you just send chunk of data around the UI, and we don't really know what is going on. And if you don't have any consistency inside your presentation layer, then all your async event or action can finally lead into something really weird. And okay, when you are at this point, you say, okay, why it is so hard to write this kind of abstraction? Why finally we fall with incomplete UI binding? Do we have bad separation of concerns? Or finally, some kind of, we can have MVVM. Is it something that is less formal than MVP, or is it something bad, or do we lose something? And I would like to push this MVVM pattern one step forward to try to bring something that is not entirely new. I would like to talk today about unidirectional data flow. That means that I would like to bring today something that, let's think about states over interaction for the abstraction of our architecture. That means that, let's see, as the unidirectional data flow, you see a circle of view, action, and state. A state is finally logical representation of your view, is passed to your view. The view triggered actions, and then the actions can update a state, and the new state is then passed back to the view. And then this is really formally unidirectional. That means that this is going in one way only. This is we are emitting state from the actions. And This is not something new. This is not something that is completely taken out of the box or out of a broken brain, let's say. This kind of approach is done since many years in the web community, and you may know one framework that is Redux from the JavaScript community. And finally, what we would like is that we want a single source of truth. We want to use immutable data to avoid any kind of UI component try to update the data on its own. And then we want to be able to have a great stability, to log everything what's going on in terms of action, updates, and then we can unlock a great replayability with all of that. That means that we can understand that finally your abstraction is sending one state, then another one, and then we can log it, and then you can track any error, any problem by those logs, and then you can replay this sequence of this state. And for the Android community, this is not something new also, because this has been, there's an interesting talk about with Christina Lee that talk about Redux, and she's talking about her team and how they implement a Redux pattern with a few classes. And you can still look at a small talk about how they bring Redux pattern in the team. You may know one well-known pattern now in Android that is MVI, which is finally the same as this Redux pattern with state, action, and view. As you just swap intent and action, and you have the same approach as we have state reducer. We have action. We have intent dispatcher. You have your model, your view. This is the same approach, but clearly written directly for the Android platform. Another good talk you may have already seen is about Unidirectional Data Flow from David Gonzalez, which also talk about a main concept of a view model and how you can place a reducer, a store, and how we can play with those components. I will come back on that later, don't worry. And another initiative that you may know is MVI Kotlin. And MVI Kotlin, as you see finally on this schema, is all this way you transform things to emit states, and you work with that. But finally, when you have to write things, especially it begins a bit verbose, as you may have you write your store. A store is where you store your state, then it's usually a live data or something else. You have a reducer that is finally a block of code that is dispatching your intent or your action to run a new state, and then and then the dispatcher that takes all the actions for that. For me, I don't want to dive into the thing that finally my view model is getting super complex, and I'm losing myself in many components. I don't want to care, because finally I have to focus on other things on my day, and I would like to avoid to have to write my own reducer. That means that to reduce my action as an emitter of a new state, and the store, the stuff that will store my states. I would like to just focus on state and events. That is finally something I would like to have this big picture in mind, and just it. That means that I just want to have this, like I have my view model that is emitting state and event to my view, and my view that is triggering action. And that's it. I don't want to care, I don't want to care more about that, because I will have to design my state, I will have to design my event, I will have to design all my data to use that. And if I have to think about all the complex stuff under the hood, then it will be very hard to go in this kind of pattern. We'll go with this idea that finally view model will offer action, and action will trigger states, and finally to test that, it will be just a matter of a sequence of state and events. That means that when I will test my action, I will just trigger my view model action, it's just a function, And then I will say, okay, I have to have in order this state and these events. And of course, we are in 2021. We need coroutines. And yeah, let's try to bring something that would help us write unidirectional data flow in an easy way of wrapping up on our view model. That means that if we can have something that brings for us an action reducer and a state store, that means that finally our view will trigger the action, dispatch this action to our magic box, and it will run the action for us, produce a new state, and then it will state to our view model that will dispatch it to the view. You can see that under the hood, an action reducer can be modelized as an actor. That means that we are enqueuing action to be run by the view model, and the state store is finally just a live data. That means that finally we just a live data stream. We can send event and we can send states. And finally, I'm working on this topic since more than 2 years now. I begin to give talk and hands-on workshop on the topic many years ago, and today and I begin to wrap up some little classes that I usually write in company and with teams, and we usually tend to write the same thing. And finally, we are rewriting these unidirectional tools. This bunch of classes can be easily wrapping up in one thing, and I wrapped it up in a library called Uniflow. And it's a little library that is super, you will see, super easy to use. And just use the Android implementation if you are using Android. There is also a pure Kotlin approach if you want with the Uniflow core, but just use Uniflow-Android, and then you can unlock a few tools to easily onboard your view models as a unidirectional data flow view model stuff. And what is important is that finally, with our time as a developer, we want, this is my point of view, but I believe that we need to focus on the value to deliver, not just tools, and not just on the technical complexity. But finally, the beauty of that is that it's easy for the other to use that, and it's super easy to build an application with such approach. It's now time to get into some code and to get the interesting part of that. I would like to share a first sample. Let's take a first action, like let's take this screen. Okay, this is a weather application where finally we want to display. It's just something that is purely static. Then we want to display the day, the weather icon, the weather description, the temperature, the humidity in the wine. And from this screen and this bunch of data, you can see the situation of something that is very simplistic, like either you are in the empty screen, either you are in the weather detail screen. That means you have your detail of the weather. And then finally, you just have two states. And we can write it as two immutable data classes, like those one. That means that you have an object class empty, and you have a classical data class here with immutable properties here. And to be able to send them to via Uniflow, we just need to make them inherit from UI state class. What is also interesting is that we use a stilled class to have a kind of contract of the state that you want to use in this view model, and then you can see all the state that are possible to be to bind for this view model. Then, speaking about view model, let's dive into it. It's a classical class, a Kotlin class that is extending a view the classical Android view model class. Then we have some repo and Why not an ID here? And what we want to do is we want to write the get detail function. Here, from here we go, we want to make an action. And an action is just a function. Then this function will trigger something that will emit a new state. And to do that, the first thing that we need is that we use the Android Data Flow class that is finally all the tools that I just talked before, the unidirectional, the Redux components, packed into your view model component. And from here, then I can use the action keyword, as you see, and it opened me a block. You see that finally I can say function get detail equal action, and we open a block, and then this block will be my action that will trigger a new state. And from here, I can emit state and event, and I can use coroutines. And by default, it's dispatching on IO, but you can specify the dispatcher you want. And as we are reducing the state, that means that we are running this action function against the current state to emit a new state or to send an event. An event will be a side effect, something that is not updating the current event. Then we can have the current state that is the current state of our view model. Let's go then. We need to get the daily forecast data, and we just make a call on our repository for that. It's a coroutine call. And what we have here is the set state function that will emit a UI state object. And here is just a mapper with the extension that will bring us the weather detail object from the daily forecast entity here. Nothing amazing. And that's it. And you see that finally, with just the action block and set state object the set state function, I can emit a new state against my current state of the view model. And this is super interesting. This is super fast to understand and to read. And you can also define the first state of your view model that is by default empty, but you can specify another one if you want. One thing that is clearly boring in coroutines is the error handling. That means that in our case, we are working with state. We want to manage to say, hey, finally, things goes wrong, and then we need to have a failed state. We could imagine something else, but let's imagine a state that is failed, and then we want to bring one message and the exception that we found. And in the case where we are using action, the traditional way to catch action, to catch exception in our coroutines would be like that. And it's a bit too bad to work with such mechanism everywhere. And one way to do that with Uniflow finally is that we can provide a second action, a second function. You see that finally the action keyword can have two sub-functions. The on action one, that is your regular action. And if you want to have a particular catch on this function, you can have the on error block that will bring you the exception and the current state, and then up to you to do what you want here. And then we can set another state. And it's a bit more elegant and a bit more interesting just to say, okay, on this action, when it's failing, I can do that or that, and do that at the action trigger level, and not doing it by hand everywhere in the code, in the action code. Okay, then once we have written our action, what we have to do is the UI binding here. And in a regular activity, we just need a view model. And what we usually do that at least on the onCreate section. What we can do, is listening to incoming state. And for that, we have a keyword that is onState, that is finally taking your view model and opening a block code for you and say, okay, here's the incoming state. And then you can use the when pattern matching of Kotlin to check all the incoming state that you want here to bind. And finally, that's it. You have your data. And we can trigger our get detail weather stuff here. If we need to listen for incoming event, this is a different stream. Then we need another keyword. We need the on event. Then we have separated channel. We have the state channel and we have the event channel. And then just with the on event block on your view model, you can listen to all the events you need. Okay, then it's fairly easy to bind in the UI side. Finally, on the testing, how it goes, then we can have some mocking API or simple observer, but here we are using mock. Then we can create mock observer, which is an extension from Uniflow that will help you create a mock with mock key framework. And then you can mock your coroutines call with co-every on the repository call here to return our weather data. We make our call. And then what is important here is that finally, we just think in terms of sequence. That means that we just think in terms of my screen is empty and then it goes with this detail, or I have this event, or I have this error state, and that's it. And it's fairly super easy to understand that an action is something that is really small, trigger just a change, and then you can easily test this kind of action sequence. And one thing to keep in mind and one thing to write is that finally, in your view model, we just write things like that. My action equal action. And then I can trigger a new state and I can trigger event. And that's it. And this is kind of magical because I don't have to have heavy concept in my mind. No, I just say, okay, here's my action. Here we go then. And emit the state you want, send the event you want, and then you are in your state flow. And this is very interesting to not carry anymore about something else. Dealing with state is very interesting in another way, that finally we can work in a sequence of state, and then we can make some guard against state to be sure that finally we go in this or this state. For this example, I will take BlaBlaCar is one of the BlaBlaCar applications, a daily carpooling application. It's for short distance. And in the profile section, we can set your company. We can either say, I don't have a company, either you want to select your company, look at the company database that is available, and then says, okay, this is my company. And then you can say to your colleagues, or you can send an invite to your colleagues to say, hey, I'm using BlaBlaCar, and then I can make some carpool for this traveling. And for such case, we are in a situation where we have two different contexts. We can be in a way that finally we don't want, or we don't have any company, and then we don't want any suggestion, and then we want to select to be there. Either we want to select a company and from the suggestion that we are looking. And for that, we are in the case where finally we have one view that will be an activity, but we are in one view with multiple state and not necessarily sequence state, but we are in multiple state. And what we will do then is that we will write those two cases with finally a seed class. Here we go. Then we want a set of state to describe the situation. Finally, we have an empty one, the first. If we are looking at company list, we will have this state where we have the list. And once we have selected one company, we will be in the state where finally we have selected one company. And in the other case, we can say we don't want any company to be selected. Then we are in this case. It's an object class directly. How to write that in our view model? Classical repository here to select some company, the Android Data Flow class. And what we have here is we have the first action, search for name, is finally looking for suggestion, and we set the company list state with the new suggestion. And then we have the first state. If we don't want to select company, we only allow that on the empty screen. That means that we don't want to allow to say, I don't want any company if I begin to be in the selection of a company. Then I have a special action here, if you see, that is action on with a type. And this will execute a guard for you. That means that finally, it will execute the action only if the current state is the empty state. And this is super useful because you can quickly write action clearly depending on the state you want to execute. The other, finally, select company is an easy one because we want to execute this action only if we are in the company's list state. And once we have this list, we can emit the company selected state. And that's it. And this is super powerful to be sure to execute action directly on the state we want. And it's you see that finally this way of writing it is super compact and interesting. Here, if you see, finally we trigger action, we dispatch the action to our component under the hood. And when we run the action, and finally when the guard can't be run, the action reducer will emit a bad or wrong state exception, and then you will have to deal with that and then handle it as a normal exception. How we can do? Either you can do that as your action level, as we have seen before. That means that you specify on your action block, you specify a second function. Either what is very useful is that finally on the Android Data Flow, there is a global on error function that lets you catch any uncode exception around. And then you can say, okay, this error is a bad or wrong state exception. I can send an event, I can set a state, I can just log whatever you want, up to you to deal with this kind of exception. But finally, when you try to execute action directly on a given state and the state is not the one you want, then we have to deal with that. A third way to deal with state and views, it's when finally it can be more and more complex. And I will talk about how we can begin to orchestrate states and views from with the state with a more complex scenario. That means that finally we will be in a activity and multiple fragment situation. That means that the activity will be in the routing position and the fragment will be sharing the view model around. And what we will have is that finally from one stream of state we will send multiple state, and then it will be boundable to the views. Then, if we have if we want to bind a same state to several portion of the screen, then fragment, we can do as follow. That means that we have one view model for our weather activity here. We are getting our detail, the weather state here. And finally, the weather activity, once we receive the weather state, will create the two other fragments to display that. Nothing specially to pass as argument or any navigation stuff, because finally those two fragments will listen also to the same view model, and as they are listening to the view model, they also will receive the same state, and finally they will receive the state, and they can bind the portion of they can bind the screen as they want. And this is super interesting because finally it's help you work in the kind of monostate approach, and then you can just broadcast this state, and then all the portion of your screen can bind this as you want. How you write it in your activity on the UI side, in your on state block, you just have to deal with the different state, and mainly with the main state, the weather state here. In the case of the weather state, we will create the needed fragment. And that's it. And on each fragment, we will just have a small on-state block that will listen to the state received, and we just bind it. And that's it. Finally, with the same state, we can bind different part of the views, and it's kind of easy to broadcast this state to all the fragments. Here, another way to deal with one stream and multiple views is where we are in the position of a workflow, and we want to have big full screen, new screen completely. And for example, I will take an example of the curve application here, where we have a workflow to add a new card, for example. And let's say we have your new card activity and your new card view model. You start the flow directly, then the start state is received by the activity, and then it creates the start fragment. Then the start fragment is listening to the new card view model, and then it can show what it has to show, the start point. Then we can edit a new card, the same stuff. Then it's a new state. It's the edit card state. Then the edit card fragment is created, and then it's receiving a new state, and then it can communicate with the new card view model. And then you can fill your data here. And then you go to the verify card phase, where finally it's a new state, and then you bring a new fragment. Then you are waiting for the confirmation of the verification. And then finally we finish the flow. We receive the last state, that is check card, and then we create a new fragment, the last one here. And then we are displaying the end of the flow, and that's it. And this is super interesting, as if finally all the logic of this flow has to be centralized, then it's interesting to dispatch the UI binding to different views, but to keep the logic in the same view model. It will be hard to have one view model per view, and then to coordinate everyone. Here, you can have an easy way to dispatch one workflow, and then to work on state, and to go forward on each step. How we write it? Very easily. In the main activity, in your on state block, finally, you will just open a new fragment on each state you are receiving. And in each fragment, you will just observe this state, the state that you want to bind, and that's it. And this is super easy, and all the workflow orchestration is done directly like that. Another thing I would like to share is that finally, with this, with the usage of coroutines and such things like we can be more safer with some functional approach, and a very well-known framework that is Aero, and we could really easily handle all the side effects directly with some basics types. That means that instead of trying to try catch and to use the on error catch here, that is already a good concept, because you don't have to care. You have your final net to catch up everything. We could use, instead in your action, we could use the either expression, the either type from arrow, and then combine all the functional approach to finally get our error or get our state in a safe way, and that emits the state, or just handle the error in a gentle way. Up to you. You see that finally it's really this kind of approach is friendly for the functional framework. And then it's interesting to see then. Another thing that is really recent is that finally this approach, this unidirectional data flow approach, is really interesting in the context of Jetpack Compose. Why? Because finally we are emitting state or bunch of screen, and then we want to refresh just this part of the screen. And then how we can write it, how we can play with Uniflow and Jetpack Compose and easily write data flow for Jetpack Compose. In the Uniflow project on GitHub, you can find one demo application from the code samples that is just Jet Survey, for those who have already played with Jetpack Compose demo application. There is one Uniflow version of the Jet Survey application. And what we want to do is finally to say, okay, I have view model state. I just want to push those state and transform those state, those logical state, as compose state. And it will be direct, it will be straightforward, and it will be clearly magic to use. What we have to do here, nothing magic, is that finally the server view model is using Android Data Flow, the class. We are in the action that is computing the result of the survey here. And then what we do is that we launch an action, we are computing all the results, and we emit a new state with the result of this for the question. Nothing amazing here. We just emit a new state. We don't have to care about anything else. And in the survey fragment, it's using its view model. We are in the Jetpack Compose hierarchy here, and then we go in the Jet Survey in the Jet Survey theme part, where we are beginning to we are writing the main stuff here. We are listening to the states. With our view model, we are writing view model.state. Then you get directly the streams of state to be observed. And why you are writing it? Because you can use the observe as state, which is an extension from Jetpack Compose to let transform any live data state as a new composable state. And then with this line, finally, we catch our logical state and we transform them into composable state. And yeah, that's it. You get your data. We have the survey state question and the survey state result, and then we can run the new screen with the survey question list screen and the survey result screen. And that's it. It's finally super easy to use here and to embed some unidirectional data flow with Jetpack Compose. Yeah, multi-platform. Good question. I believe it's a great question, and I believe it will be super interesting to see how finally we can share common code about view model and mainly data flow, and how we can finally share this in the multi-platform side. I can't share this with you today. So Roberto, we show you more things about multi-platform after me. So it's almost finished for me. Then are you ready to write the states? I believe finally that in all of this, whether you want to use Uniflow or not, whether you are using another framework, MVI Kotlin or whatever, you have to make your own experience of that. And what is the most significant part is that you finally have to shift your mind to think your logic as state. And you will make unidirectional data flow. And finally, like all architecture approach, this is really hard stuff that are stuff that are hard to change in your application. But finally, it's clearly isolated on the presentation logic. Then you can try it, you can play with it, you can try to experiment on some screen with it. And I would say that finally, it's one architecture design approach, but we have many ways to write it. And I like to try to simplify the way we write it. I believe we need to keep focus on what we deliver, and we need to be focused on what matters. And clearly, if we have time to understand what there's under the hood, on our day-to-day, we need to deliver things. And I believe if you are not cluttered by tools, then you are in a great position to deliver value. If you're still interested by Uniflow, you can check on GitHub. There's the uniflow.kt framework. And that's it for me. Hope I'm still online, and we can go for some questions then.
Yes, we have a few questions. I'll put them in the stream right now. First of all, thanks for your talk. Really, really interesting. So, first question from Eugene Martinov. State emit is reactive. Why not also to have user intent reactive out of the library?
To have user intent reactive out of the library. Yeah, I don't see clearly what is it, but it would be like considering the action triggering as a reactive. I mean, like it's not. I don't think. Yeah, it's not something that comes into some requirements for me, and I don't think this is close to this kind of approach. You could emit in the way you want, but it's not something that is taken into account on this side. Then the reactive approach is only from the presentation layer, your view model, and your view. But could be interesting to see if there is any interesting things to add. John?
Yeah, well, John was asking for some example Uniflow library with Japan Compose, but you already showed them.
Yeah,
so I
exactly.
think they're fine.
Exactly.
Yeah. Another question from Eugen. Why exception choice? Will it crash the app if no on arrow is overridden?
Yeah,
I think this was like
it was a hard choice, and finally it's hard to take a decision to say finally it will be always in the same case. That means that finally you can take the end on what you can take the end on the exception management system. Up to you. If you don't do anything, it will crash, but up to you to catch the thing you want in the way you want to finally send state, send event, just log. Because finally, it depends on the error. It depends if it's a business error. It depends of many things. And at the beginning of Uniflow, we were pushing event in the default way, but finally there were many situations where people could handle it directly, and finally I prefer to let the choice, or also feel free to give some feedback if we can improve that also. Yes.
Nice. Another question. So, have you thought about a separate arrow library artifact to replace the action keyword?
Like the IO, I believe Tobias is perhaps thinking about IO effect. I didn't dive into it too much. It would be interesting to see how I could clearly embrace the arrow library a bit more with that. To see, to be honest, I believe like IO effects are more lazy in a more lazy approach than Uniflow that is trying to execute it directly on the dispatcher, then would be interesting to see if there is a more interest in that.
Okay, I think that was it. A lot of thank you to you for the interesting talk. So really nice done.
Yeah, thank you.
Thanks again, Arnaud, for being with us. Cool, thanks.
Very happy. Thank you for sharing this with me.
So we can go now to our second speaker. So we have a hot topic in the Kotlin community. We already have some talks about Kotlin multi-parameter in the past. We have it this month, and we have it in the next few months. So Roberto Orgiu will give us his view as an Android developer to Kotlin MPP. So it's over to you, Roberto.
Yeah, thanks, and hello everyone. Thanks for being here. So let's get started. So in this talk, I'd like to get you started on Kotlin multi-platform, but from an Android engineer point of view. So that's why there are a few premises that I'd like to make. First of all, I am an Android engineer. And that's the first and probably the most important premises of all. The second one is that I have no interest in being a fully closed platform developer. And slightly less important in our profession, because we always have to learn new things and everything. I'd love to be able to reuse everything that I learned so far. And if not everything, well, a good chunk of that. For instance, every time I use the Java programming language on Kotlin on Android, I feel like I've never used it. So, given these three premises, well, the only language we can use is Kotlin. And it's actually pretty good, right? So, of course, Kotlin is not the only choice. Because if we only if we want to avoid JavaScript at all, we could still switch to Flutter. But yeah, the problem I personally have with Flutter is that I would need to use Dart, which would be totally fine if Kotlin wasn't around, because it would be a huge improvement over Java. But there is Kotlin, so yeah, I prefer Kotlin. Of course, we can't write everything in Kotlin, and we have to deal with Swift. At least for this example. So, for what concerns what we're gonna build, well, we're gonna build an app that will show the lights, or the lights color of the Empire State Building. So a few years back, they added a whole new system to reproduce new lights for the Empire State Building, and based on the occasion, the building will be enlightened with different colors. I'm a huge fan of this building. Every time I go to the office, I take a deep breath, stop, and watch the Empire State Building, because I think it's a magnificent building, one of the most beautiful skyscraper that I've ever seen. So I decided to build this app and build it for, well, both platforms, both Android and iOS. But how can we do that? Well, we need basically three frameworks. The first one is Ktor. The second one is Jetpack Compose. Well, of course, I could have used views, but as Arnaud mentioned in the previous talk, well, we have Compose that plays nicely with almost everything. So why not? And of course, for what concerns iOS, well, the only choice is with UI. Given that I wanted to use Compose on one platform, Swift UI seemed like the good approach on the other. We won't dive deep into these three frameworks, but we'll see a little bit of all of them. We won't really see all the backend part of KTOR. We will see more the client part, but more on these in a few minutes. So let's start with an overview of a normal application architecture. So the first thing that we clearly have is an activity. I mean, we tried to avoid having them, we added fragments and whatever, but we still need an activity. So let's give that for granted. And now, most of the times, well, we might need to use a view model that comes from Jetpack. So we're sure that these two things are totally Android. Then, most probably, if you make network requests or read file from disks or from database or from cache or whatever, you might have a repository. And then, of course, there is the backend. So, for the moment, we want to focus just on the repository because this is what we can share, we want to share. The rest comes from Android, or it's basically equivalent, will come from iOS, but the repository, we're pretty sure that this is only Kotlin. Yeah, that's really not always the case. In my case, I was used to use Retrofit for network requests and JSON or Moshi for serializing and deserializing the content. Well, unfortunately, these libraries don't really get along with Kotlin multi-platform. But we are pretty lucky because there are other libraries that actually work pretty well with Kotlin multi-platform. And those libraries are KTOR and Kotlin X serialization, both developed by JetBrains, and well, they both work on several environments, included Kotlin multi-platform. So if we switch from Retrofit and JSON and Moshi to KTOR and Kotlin X serialization, we're pretty sure that everything we write is totally Kotlin and can be shared with multiple platform and environments. At this point, well, we really separated everything that is Android that will go in a native module, something that is pure Kotlin that goes into a shared module, and then our backend. Of course, while we can write all our Android code in Java, it's needed that we write our shared module code in Kotlin, which is a very good thing. I mean, I suggest to write also the Android part in Kotlin, but that's another topic. But it's not only the repository that can go inside the shared module. Actually, all the business logic, in our case, is simply a repository because, well, the app didn't have any complicated business logic, but everything that is not strictly dependent from Android or iOS can be shared. The only concern that you want to take attention to is that the libraries are actually ready for Kotlin multi-platform. Otherwise, even if you write plain Kotlin, chances are it's gonna be more problematic to share this code on iOS. So while you might write plain Kotlin, once more, be aware of the fact that the library must be ready for Kotlin multi-platform. And they usually say that, so that's good. Okay, so we need to start our project. Of course, since we are, I'm an Android engineer, what I want to start from is Android. So when I first started working on this project, it was quite complicated to set up everything. Kotlin multi-platform was not yet as easy to use as it is today. And well, the vast majority of my talk covered how to set up properly the project. So let's dive deep into this topic. Luckily for us now, we don't really need to dive that deep because there is a plugin that does all the setup for us. So this plugin is called Kotlin Multi-Platform Mobile, and it comes from JetBrains. The only thing you need to do is go into the marketplace, either on Android Studio or IntelliJ, install it, and restart your IDE. Once your IDE restarted, you create a new project and you scroll all the way down to the last of the templates. You select the KMM application template and follow the steps until you get to the very last window. In this window, you'll be able to choose the name for the module of your Android app, the name of the module for your iOS app, and the name of the module for the shared code. And one thing that I really love about this plugin is the fact that there is the option to automatically create sample tests for the shared directory, which is super useful because since we're writing business logic, chances are we want to cover it with a lot of unit tests and everything, and have everything already configured. It's actually pretty nice. And once you press on the finish button, all the directories will be created for you, and you are almost ready to start writing some code. I said that we are almost ready because we need to wait for Gradle to sync everything. Otherwise, you might get these kind of errors because what happens is that when you declare something as expected on your shared module, you need to wait for Gradle to sync everything and all the directories to be ready and available with all the actual implementations. Otherwise, it's gonna give you some errors like this one in which I wanted to start typing before the iOS folder was pretty synchronized, built and everything. And the IDE will tell me that, well, I didn't have any platform name declared inside the iOS module. It's nothing to worry about. You just need to wait a little bit. Usually the first run took me a couple of minutes, not more. So it's important to know that this might happen in case. Just wait and everything will solve by itself. Okay, now we are really ready to write some code and we can start from the models. So the models that we wrote are pretty simple. So starting from the first one, this is the calendar, or what I call the calendar. Basically, is the representation of the next available lights. Since the website, the website doesn't provide API, so we needed to scrape the data and show them as JSON. But the website is very nice in in the fact that they actually share multiple days. So you are able to plan ahead your visit if you want to. So for every day, we have an image to show how the Empire State Building will look like, the name of the color, which is an HTML formatted color. So it will be blue, dark blue, or deep red. There will be one of the 144 colors, HTML colors, most of the times, apart from some rare occasion where they have very different names. Then there will be a reason for the color to be in that case. For instance, on Columbus Day, they usually light the Empire State Building in green, white, and red. And there is the date that this light will happen in. So in this case, I represented the date as a string because I'm representing it exactly as it comes from the website. It will be in the format 4 digits for the year, 2 digits for the month, and 2 digits for the day. The next model is basically the response that we're going to get from the server. Because even if on the calendar we have the previous or following days, we still get the color that we will see today as the first element, or as the root element of our response. Unfortunately, for this color, we don't really have a reason because it's not part of the information that we get, but we can still get a color, a URL for the picture, and of course, we have the list of the following days or previous days. It depends on where you are in the month. An important thing to notice here is the fact that the annotation at serializable that comes from the Kotlin serialization library is basically the only thing we need to get this model to be serialized and deserialized from JSON. So once we create our models, we add the annotation, and that's basically done. Of course, these models should go in the shared folder because we're going to use them for both Android and iOS, and so should the repository. In this case, the repository is pretty simple because I really wanted to only highlight how Ktor client would work, and it works in a very different way from what I was used to with Retrofit. So the first thing that is different is that in here we build an HTTP client that connects to different endpoints without the need of a root endpoint. We don't need to build. Well, we can pass different parameters, but we don't need to build a retrofit interface and then pass in our network interface so that the proxy can be created. In here, we don't really create an interface with all the calls and response, but we'd rather set the endpoints and what this endpoint will return. So in this case, we're going to create an HTTP client, which is the first thing we do inside the repository. And in the building Lambda, we're going to install the JSON feature. At that point, we need to create our JSON rules, in which we say that we want it to ignore the unknown keys. Otherwise, by default, it will crash as soon as it will encounter a key that is not defined in our model. At this point, we set the Kotlin serializer with the JSON we just created as the serializer for the HTTP client. And of course, this HTTP client is coroutines ready, so we just need to create a suspending function that returns the lights model that we just created, and inside we invoke the get method on the endpoint that we want to target. HTTP client comes with all the HTTP methods, so get, post, delete, put, and all methods, and they are all suspending functions, so it's super easy for us to use them. Then, unfortunately for us, we need to switch back to Android in order to use the repository. We could do that without, but since we have view models, we really want to leverage them. So this is a normal view model that we might have. In here, I didn't really use dependency injection because I only had one single dependency, and it was probably an overkill for the sample project. But in case you want to use a dependency injection framework, Coin works pretty well with Kotlin multi-platform, so it's pretty easy to set up and use, and you can use that in Kotlin multi-platform. Another thing to mention is that here I used two left datas, just because out of habit. It will work with just one left data. But now let's focus on how we can use the repository. So I normally use an LC pattern. That means that I usually emit a loading event, then I will make the network call or this call or whatever, and return either the success or the error. Everything is encapsulated inside the view model, so that if you want to refresh or retry, you just invoke the view model again, and the flow will start exactly in the same way. So the first thing that we are going to meet is the loading event. And for what concerns the rest, we just invoke a coroutine from the view model scope, and we use the view model exactly as we will do with anything that is in our Android model. So for what concerns Android, it doesn't really change much, apart from the fact that we need to switch some libraries and we need to put the repository somewhere else, which is just another module. At that point, we just wrap the success event, or the response inside the success event, or an exception inside an error event. And that's really it. Once we want to use, once we are there, we can get our view model from with the by view models delegate, and we can use it inside compose. This case is one of the ways in which you can observe the view model, but it's pretty outdated. As of today, I would suggest to pass the view model to your UI, and instead of invoking the observe method, you can use the observe state that will give you a state. That way, your UI will react more naturally to what you're receiving. So while these work, and these will work in both the view world and the compose world, if you are targeting compose, you probably want to use something more composite, let's say. So of course, these all look super easy, but unfortunately, there might be some very weird errors that will actually happen. I mean, they happen to me quite a lot of times. The first one that happened really too many times that I'm comfortable actually saying, it's this one, where it told me that there were some unsupported modules detected in the shared code. While this is scary, The solution is pretty easy and straightforward. So what we need to do is close our project and IDE, delete the .idea directory and all the .iml files in the project, and report it. And it will work. I honestly don't know if it was me or my IDE or anything, but I had this a lot with a couple of version back of the Android Studio Canary. Hopefully, well, it is now why that it doesn't happen. Hopefully, this is gone. But there is another error that was slightly more complicated to figure out. And it was this one. So, well, this one, it told me that basically I needed to initialize at least one Kotlin target in the shared module. I tried to understand exactly what that meant, and the solution was actually much easier than expected. I tried everything, and the solution was as simple as upgrading Gradle to the 6.7 at least. My personal advice is that JetBrains is very active on Kotlin multi-platform model. So whenever you encounter something that you don't really know what that means, chances are that there is already some issues on their issue tracker. So I was lucky. This same issue was already in the issue tracker, and the solution was ready. But that happens with more errors. So whenever you have an error, just check the issue tracker, and if not, open one. They will be super fast in replying. Now, we said that we wanted to talk about the other platform, iOS, and so we will. To be honest, that was my very first project on iOS, so I didn't really need anything. I didn't know even the Swift syntax. But luckily, there is an amazing code lab from developer advocates at JetBrains that will teach you everything you need to get started, including using a SQLite database for storing your data. So in case you want, that's the short URL for the code lab, or you just need to type Kotlin multi-platform mobile code lab on Google, and it should be the first result. So the first thing that I really wanted to do on iOS was using coroutines. So I noticed that inside my Kotlin file, there was an iOS scope, and I really wanted to use my coroutines is exactly as I wanted to use them on Android. Yeah, it turns out, well, I totally didn't forget that they were extension function and they cannot be used in this way in Swift. One very interesting bit that I noticed is that the Kotlin files are transformed into Swift in the exact same, well, not transformed, sorry, you will refer to them in Swift in the same way you would refer them in Java. So by using the file name and KT afterwards to get to basically access their methods. So since we cannot use coroutines in this way, but there must be another way to use them. And well, we have the equivalent of a view model, basically, but not really the equivalent, but they're used mostly in the same way. So one thing to notice is that in iOS as well, you have the same LC pattern. In this case, it's declared with an enum. On Android, I would use a sealed class with an object for the loading and two data classes for the success and error. In here, they are case in the enum. The next step is declaring the view model as an observable object so that it can expose the repositories, well, more than the repository, it can expose the events that we just created, so the loadable lights events. One thing to mention is that we create our lights variable with the @published annotation, so that when it changes, it will emit again, I suppose. And we use as starting value the loading one. Then we need to pass in the repository to our view model, and we invoke the load lights right away. But let's focus a little bit on the load lights method, because this is where we're going to use coroutines. So once more, since we might want to rerun this function multiple times, we set the lights value to the loading one. Then we invoke our repository, and more or less like we will do with Java, we need to pass a completion handler to as a parameter. This completion handler, will be constructed by a lambda that has two parameters as input, lights and error. Lights, if lights is set, it will contain our result, otherwise we will have the error. So what we do here is basically the same thing that we did on the Android view model. Whenever we get back the response, we check if we have the lights value, we're going to return the result, otherwise we're going to return the error with the localized description. So once you created all this stuff, it's time to actually use it. And how we use it? Well, we basically listen for the events like we will do with compose, and based on the type of the event, we will create a loading view that just says loading, the success view that will show our lights, and then the error where we're going to show the error. So once all of this is set up, we can start thinking about the UI. So I won't show everything related to Compose Swift UI, but I wanted to highlight a very peculiar aspect of the two compared. So the first example is Compose, where we have a function that will return a text composable that takes a lot of parameters that will define exactly how our composable will look. So we have the text, we have the color, we have all the modifiers. In this case, we only use padding. We have the letter spacing, and everything is basically passed as a parameter. On Swift UI, instead, we have a more fluid syntax. So the only needed parameter for our text element is the label that we want to display. Then we can append a color, we can append a padding, and we can append other modifiers. Personally, I would prefer the one with Compose, so that you can nest all the composables in the way you want. While I find it harder to nest anything inside a text element of Swift UI, it's not said that you should do that in Compose either, but I like the fact that it's actually doable. So after we saw how those two framework compares, this is how the UI looks like on Android and on iOS, and they work exactly in the same way. On Android, I use the swipe to refresh to reinvoke the view model function. On iOS, I had a reload button that did almost the same. I tried to have the same UI on both. I did not really succeed to have it exactly in the same way, but it was pretty close. And I have to say it wasn't that complicated. And with that, I'm done. Feel free to follow me or ask me on Twitter any question if you feel like. And thanks for listening to this talk. And I guess that now is time for Q&A, if you have any question.
Pardon me, I was muted. So let's see. First question we have is from Shervin. Hope I'm pronouncing that correctly. So, what's the best practice to using date in an entity which is defined in a shared module? Imagine common date related operations are required by that entity.
Yeah, that's a very good question. So as of today, I would use, as an Android developer, I would use a local date that comes from the new Kotlin Date library. That is, again, ready for multi-platform. And I think that it's more or less standard. If you're familiar with local date time, offset date time, all these permutations, it will be mostly the same. At the time of writing of this talk, I didn't really need to use that library, but I plan to use it in the next iteration of the project. Otherwise, if you are on the back end and want to share the date, I find myself pretty comfy with the ISO 8601 format. So basically, you would have year, month, day, T, and then hours, minutes, seconds, and offset from UTC. So you would have everything you need to parse that date easily and automatically with almost every date library.
Always good when you go with a standard. Cool. The next one is from Eugene. How is flexible Kto for extensions? Can you compare it to retrofit?
That's another good question. It depends because they solve different needs. So while I think that retrofit is great when it comes to have multiple calls and divided probably in different endpoints or even different servers at all, Ktor is Ktor client is more a part of the whole Ktor set. So my personal opinion would be that if I had many calls, probably I would have missed retrofit because of the fact that that I'm more familiar with it. Both Ktor and retrofit can be extended, but as an Android developer, I would rather use retrofit since I know it more. I know, for instance, how to enable a network logger, how to add all the others I need. I'm pretty sure that this can be done with Ktor as well. But I think that on that side, I would prefer retrofit more for the proxy logic. So you can have everything tidied up in one interface rather than having your call mixed in the repository, which is fine. It's just a different approach. I prefer retrofit personally, but they work both fine. So I think while they're both flexible, it's more a preference than which one would work better in this specific scenario.
Yeah, when your product owner is busy or is pushing you to get a feature, you don't really want to be learning a new language, a new feature. I think that's all the questions that we have. So I'm going to hand over to Enzo.
Hey, thank you, Roberto. I see a few thanks in the chat as well. Thanks for your answer. So again, thank you very much. Really nice talk, and hope to have like more multi-platform in the coming month from other point of view. But well, really good. Thanks.
Yeah, thanks for having me. It was nice to be here. Thank you very much.
Thank you. So I think that's it for this episode of Kotlin London. We'll be back on the May the 5th, so put it in your calendar. Thanks again to Arnaud and Roberto for their time, and to you for tuning in. We hope you enjoyed the talks. Remember, you can rewatch all the talks in the previous month on the YouTube channel, so have a look. They are all already there, and most of them are really cut into so small chunks, so you don't have to watch all the live. Thanks to Pablo, who step up the last second while I was having an issue with the camera. And from Guillermo, Pablo, Amar, and myself, stay safe and see you next time. Bye.